So I recently stumbled upon a video by a guy named DIY Jarek who talked about plate type heat exchangers for residential use and how to DIY them. And I fell down a very similar kind of rabbit hole 1 or 2 years ago and just wanted to share my thoughts and what I think is going on with these plate type heat exchangers exactly. So I did it very similarly. I was pressing the heat exchangers on 3D printed pressed dies, which I just used in my vise, and I used 50 thousandths millimeter aluminum foil, but this was not stable enough. Afterwards I used 200 thousandths millimeter aluminum foil, which you can see here, and I managed to cobble together this heat exchanger, where if you lift up here, you can see that's pretty much the only open spot. Everything else is sealed quite well. Here all the edges were sealed with super glue, and this is quite airtight. And it performed really well, but only with high airflows. With low airflows, I ran into the problem that actually the very good thermal conductivity of the aluminum foil is your enemy, because while the air goes from this side to this side, from the outside to inside, and from this side to this side, from the inside to outside, you want good thermal conductivity through the actual sheet of foil, but not alongside the sheet of foil, because then you lose all the advantages of the cross flow or the reverse flow heat exchanger. And I did some tests. Again, it's been many years ago, and this here basically was my setup. It was very crude. I had some candles here and 2 Noctua 80mm fans pushing air through the contraption, through the heat exchanger. And with high airflow rates, again, it worked quite well, but with low airflow rates, which are needed for lower noise, basically, it didn't work as well anymore. So then I got back to the initial idea, which was 3D printing the heat exchangers. And here you can see some examples of this. This is a complete 3D printed heat exchanger, just like this one, the later iteration. It's a bit bigger, and all of this was 3D printed, and it worked a lot better, even though the thermal conductivity was lower than the aluminium plate type heat exchanger. And this has not been designed in a CAD software. It has been designed directly with the G-code scripting tool, I would say. I don't know what the name actually is, but it's called fullcontrolgcode. And you can write a script that directly punches out G-code. So this means that you can print all of this heat exchanger more or less in one go without retractions or empty paths. And by printing this without any additional stuff needed, any additional tool paths, you can punch it out with a really high printing speed. This is about 600 grams of PLA, and it's been done in about 5 hours. And it worked really like a charm. And the plan I had was to print many of these. This is the housing. This was printed on a Prusa XL, where all of this goes into. And yeah, you're asking why I didn't follow through with it. Actually, it's the kitchen stuff which we have, which draws air from the inside of the house, and then it kind of neglects the fans which are within the heat exchanger. So air will flow through the input as well as through the output tube into the house, and then all the kinds of heat exchangers don't work anymore. So thank you so much. I just wanted to get this out. Maybe someone can make some use out of this information.